All right, in this video, we're going to take a look at some more examples of verifying trig identities. So, part C, we have secant of theta over 1 minus the tangent of theta equals 1 over cosine of theta minus sine of theta. So, I have secant, tangent, sine, and cosine. Um, Although it may look like I'm really getting into deep trouble here, if we convert the left-hand side to use only sines and cosines, we'll have the secant is 1 over cosine all over 1 minus tangent is sine over cosine. So using our reciprocal and quotient identities respectively. So we do have on the left-hand side, let's focus on the left-hand side, we do have a complex fraction, which these tiny denominators are cosine theta. So if we multiply the entire numerator and entire denominator by cosine theta, that will clear out these tiny fractions. So in doing that, 1 over cosine times cosine gives us 1. Cosine times 1 is cosine. And then minus sine over cosine times cosine is sine. So we've actually shown that just by converting the left-hand side to sines and cosines and then taking care of our complex fraction here, that we're already done. We've already gotten the left side. We've shown the left side is in fact equal and identical to the right side. All right, part D, 6 times the secant of theta times the tangent of theta equals 3 over 1 minus the sine of theta minus 3 over 1 plus the sine of theta. So here, let's start by looking at the left-hand side. 6 times secant times tangent, if we use sines and cosines again, is 6 times 1 over cosine times sine over cosine, which gives us 6 sine theta over cosine squared theta. Okay, now let's focus on the right-hand side. So we have 3 over 1 minus sine theta minus 3 over 1 plus sine theta. So we're subtracting rational expressions. We need a common denominator. So to get a common denominator, look at the first expression here, 3 over 1 minus sine theta. Multiply the numerator and denominator by the other denominator, 1 plus sine theta. And likewise, with minus 3 over 1 plus sine theta, we're going to multiply both numerator and denominator by this other denominator, 1 minus sine of theta. So when we do that, we get 3 plus 3 sine theta over 1 minus sine squared theta, and then minus 3 minus 3 sine theta, so distributing this 3 to both terms, over 1 minus sine squared theta. So now we have a common denominator. We can combine, so we have 3 plus 3 sine theta. Don't forget this minus here means we're subtracting not only this 3, so minus 3, but also we are subtracting a negative 3 sine theta. So what we actually have after this first numerator is minus 3 and plus 3 sine theta. And then 1 minus sine squared is cosine squared. So combining like terms in the numerator, the 3 minus 3, those cancel out to zeros. 3 sine theta plus 3 sine theta is 6 sine theta all over cosine squared theta, which is what we showed in that the left-hand side was equal to. So looks a bit challenging, but just some basics on like denominators and combining like terms. All right, I believe this one is the last example in this video. So example 6e, we have the sine of theta over 1 minus the cosine of theta equals 1 plus the cosine of theta over sine of theta. And over here on the right, I've noted that this is the half-angle tangent identity, which we'll look at in a future video. So let's start with the left-hand side, sine over 1 minus cosine. Well, if we multiply the numerator and denominator by the conjugate of 1 minus cosine, which is 1 plus cosine, we get sine times 1 plus cosine all over 1 minus cosine squared. So again, 1 minus cosine times 1 plus cosine is 1 minus cosine squared. And notice I didn't distribute the sine to the 1 and the sine to the cosine. I left it factored out simply because over here on the right-hand side in the numerator, we have 1 plus cosine. So since I was multiplying by 1 plus cosine, I want to keep that, which means distributing the sine through is going to give me sine theta plus sine theta cosine theta. And that's really going to be more work than I want. So in our denominator, we have 1 minus cosine squared. That's equal to sine squared. And then sine of theta over sine squared theta, one of these sine thetas in the denominator is going to cancel out this sine theta in the numerator, leaving a 1 in its place. and we'll get 1 plus cosine theta over sine theta after canceling these two sine functions. So we've shown that working with the left-hand side, we've used some algebra to show that it actually does equal the right-hand side. And we will come back to this identity in a future video. So, all right, that about does it for this video. Thanks for watching. I'll see you next time.